Good morning, student. In the continuous series of surface chemistry, we discuss about the relationship between extent of adsorption and concentration. In previous video, we discussed about the Freundlich adsorption isotherm, in which we can establish relationship between extent of adsorption x by m and pressure. These things are already discussed. So today we start with a new relationship, which is x by m proportional to c to the power 1 by 2, c to the power 1 by n, or x by m is equal to k c to the power 1 by n. This is the same as the Freundlich adsorption isotherm, but in this we relate with the concentration. C is the concentration. So I understand that all of you understand in very well manner. This is the another kind of relationship. Freundlich adsorption isotherm is x by m proportional to p to the power 1 by n. So here also x by m is proportional to c to the power 1 by n, and when you also modified the above equation by taking logarithm both sides, log x by m is equal to 1 by n log c plus log k, and while plotting a graph between log x by m and log c, then an intercept graph is obtained. Intercept giving the value of log k, intercept is equal to log k, and slope is equal to 1 by n. Slope is equal to 1 by n. This is the intercept. Intercept is equal to log k, and this is a b theta. The slope is equal to 1 by n. So these graphs are same as with the Freundlich adsorption isotherm. So here we establish the relationship between logs x by m and log c. So intercept graph is obtained, and this is the useful relationship. After that, I am discussing about another topic of this chapter, which is actually removed in the 2021 syllabus, but we provide some concept regarding the topic, which is catalysis. What is catalysis? Catalysis is a process or the reactions which are proceed under the influence of catalyst is known as catalysis. The chemical reactions which are produced under the influence of catalyst are known as catalysis. There are two kinds of catalysis. Number one is the homogeneous catalysis. Number two is the heterogeneous catalysis. There are the two kinds of heterogeneous catalysis. There are the two kinds of catalysis process. What is catalysis? The chemical reactions which are proceed by the influence of catalyst are known as catalysis. That means the chemical reactions which required catalyst, which helps in the proceeding of the chemical reactions, are known as catalysis. So once again, the definition of catalysis: catalysis, the chemical reactions which are produced, which are carried out or produced under the influence of catalyst, is known as catalysis. So hoping that all of you understand about the catalysis. And catalysis are of two types: homogeneous catalysis and heterogeneous catalysis. And now we discuss about the homogeneous catalysis. When the catalyst and the reactant are in the same phase. When reactant and catalyst are in the same phase, then it is said to be homogeneous catalysis. Homogeneous catalysis. When reactant and product are in the same phase, then it is said to be homogeneous catalysis. Example of homogeneous catalysis: inversion of sugarcane. Inversion of sugarcane or inversion of sugarcane C12H22O11 in the liquid phase, water also in the liquid phase, and the acid used as a catalyst are in the liquid phase. This is the catalyst, and forms C6H12O6 plus C6H12O6. So all of you seen that catalyst and reactant both are in the same phase, hence it is the example of homogeneous catalysis. Another example, hydrolysis of ester. Example number 2. Hydrolysis of ester. Example number 2. Hydrolysis of ester. CH3COO C2H5 ester plus water liquid. Here also acid in the form of catalyst. यहाँ पे ये catalyst, it serves as catalyst. So reactant and catalyst are in the same phase. Hence this is the example of homogeneous catalysis. So homo means same. When reactant and catalyst are in the same phase, then it is said to be homogeneous catalysis. Next topic, which is heterogeneous catalysis. Heterogeneous catalysis when reactant and product are in different phase, then it is said to be homogeneous catalysis. Understand? Example of heterogeneous catalysis. Heterogeneous catalysis. Example: N2 gas plus 3H2 gas. Here we use iron as a catalyst. This is the catalyst which is in the solid form. Catalysts are in the solid form. Two forms ammonia, NH3 gas. Here iron in the solid form, but the reactant are in the gaseous form. So it is the example of heterogeneous catalysis. And now we discuss about the another topic, which is Adsorption theory of heterogeneous catalysis. Adsorption theory of heterogeneous catalysis. There are some points related with the heterogeneous theory of heterogeneous catalysis. So we discuss right now point wise. Now, student, we discuss about the adsorption theory of heterogeneous catalysis. According to the modern approach, this theory includes mainly 5 points. Number 1, diffusion of reactant on the surface of catalyst. First of all, we diffuse the reactant over the surface of catalyst. Then adsorption takes place. Second point, adsorption of reactants molecule on the surface of catalyst takes place after the diffusion of reacting molecules over the catalyst. Then in between them, catalyst and reacting molecules, chemical bond formation takes place. So point number 3, chemical reaction takes place on the surface of the heated catalyst through formation of intermediate. Then here intermediate will form, and then intermediate transform into the product. Then desorption of product molecule from surface of catalyst takes place, and finally product diffuse out from the surface of catalyst and exist as a product. So these are the main 5 points related with the adsorption theory of heterogeneous catalysis. Once again, number 1, first steps is diffusion of reactant on the surface of catalyst takes place. Number 2, adsorption of reactants molecules on the surface of catalyst takes place, and then chemical reaction takes place the surface of heated catalyst through the formation of intermediate reactions. So reactions will take place, and then it forms intermediate or activated complex. Then desorption of product molecule from the surface of catalyst takes place, and finally product diffuse out from the surface of catalyst. That is why finally catalyst play important role in the formation of product. So these are the main points or main theory of the adsorption theory of heterogeneous catalysis. It is excluded from your syllabus. It is not present in the syllabus of 2021. So please, but it is a part of the chapter, so I will explain. It is not required for the examinations for 2021. Safe selective catalysis. The catalytic reactions which depends upon the pore size of catalyst and the size of reacting molecules are known as safe selective catalysis. The well-known example of safe selective catalysts are zeolites. Zeolites are the honeycomb-like structure which are microporous aluminosilicates, and as for example, ZSM5 is a kind of zeolites. ZSM5 is a kind of zeolite which are used in the conversion of ethanol into gasoline. Gasoline means petrol. So it is the example of safe selective catalyst ZSM5. Several times this question has been asked in the board examinations. What are the safe selective catalysis? The catalytic reaction which depends upon the size of reactant and the pore diameters of catalyst are known as safe selective catalysis. Zeolites acts as safe selective catalyst because it is microporous aluminosilicate and it has honeycomb-like structure. So it is responsible for the particular reactions For example, ZSM5, it is a kind of zeolites which are used as a catalyst in the conversion of gasoline into, sorry, ethanol into gasoline or petrol. Hoping that all of you understand. Now we discuss about the another thing, which is catalytic promoter. These are the substances which enhance the activity of a catalyst. For example, in the synthesis of ammonia, molybdenum acts as a promoter to strengthen the activity of iron catalyst. So once again, catalytic promoters are the substance which enhance or increase the activity of a catalyst. Similarly, catalytic poisons, these are the substance which lowers down the activity of a catalyst. For example, sulfur and quinoline acts as a catalyst poisons in the Rosenmund reactions. It slow down the rate of the reactions. So these are the two terms, catalyst poison or catalyst poison and catalyst promoter. Now we discuss about the selectivity of a catalyst. Selectivity of a catalyst is the ability of a catalyst by which they have an ability to direct a chemical reactions. Which can you explain with the example? Now student, all of you understand the selectivity of a catalyst. Actually, in these three examples, all of you seen that reactant are the same: carbon monoxide and hydrogen, carbon monoxide and hydrogen, carbon monoxide and hydrogen. But there is a different catalyst. When you use zinc or Cr2O3ZNO as a catalyst, then the product is methanol. But when you use copper, then the product is formaldehyde. When you use nickel, then product is methane and hydro water. So by using this equation or these reactions, all of you understand that catalysts have an ability to direct a chemical reaction. For this example, you seen that the product is methanol. When copper, product is formaldehyde. When nickel, product is methane and water. So this is the selectivity of a catalyst. Selectivity of a catalyst is the ability of a catalyst to direct a chemical reactions. Now we discuss about the activity of a catalyst. Activity of a catalyst depends upon the strength or extent of adsorption of a catalyst. A good catalyst having the higher extent of adsorption, that means their activity is high. Therefore, in the transitions element, we mainly used as the element of group 8, 9 and 10 as a catalyst. Why? Because they have high activity. So this is the activity of a catalyst. Activity of a catalyst means it is the ability of the extent of adsorption. Those catalysts which have higher ability to adsorb, that means they have higher rate of or extent of adsorptions, having or showing higher activity. So these are the few terms. And another things we discuss about the enzymes. Enzymes are the biocatalysts which can catalyze the biochemical reactions and helps in the digestion of food materials. And the function of enzyme is based on a key and lock mechanism. For example, all of you know that every lock having the special key by which they open. So in the same way, the molecules, biomolecules such as protein, fat, carbohydrate, a specific kind of enzymes act over it. So that is why the function of enzyme is based on key and lock mechanism, and it is completed in two steps. Firstly, enzyme acts over the substrate molecule and forms enzyme substrate complex. Enzyme substrate complex, and that is further step number 2. Now enzyme substrate complex decomposes and gives product, and enzymes once again separated out. So these are the some concept regarding the function of enzyme. So I am hoping that all of you understand in very well manner. So please, these topics are completely deducted from the examinations of the student belonging to session 2021 in the pandemic conditions. This cut is done by the CBSE. So I am hoping that all of you understand. So in this video, entire things are discussed which is not asked in the board examinations. Okay, thank you.